Thank you, Burhan. So one good thing about going last is that I have this piece of paper that I prepared to talk about things to plan things I want to talk about. So let me go through them real quick. So CI is cool. That's been talked about. Argonne is cool, so we're done with that. Big data management and analysis is cool. Ravi covered that. So I'm done, actually. This is going to be a big, long pause. I'm going to stare at you, and you're going to stare at me back. But one thing that nobody, and I don't think anybody talked about, is that at CI, you get to change the world. Right? You get to work on projects that have a great impact that has potential to change the world. That's one reason why I'm here, and that's one reason that I hope you take it away with you. We do a lot of great projects across multiple disciplines, and I'm really happy that I'm not figuring out what next ad to show you when you're looking at your email and Gmail in the next 2 microseconds. I want to print out the ad for Viagra. So I'm not doing that. So I'm doing something that's meaningful, as Raid said, and that resonates with me. And, so one thing that we in Ian's group and the University at CI and Argonne, we work on creating services for science. What that means is that we understand, and we agree that a lot of basic sciences have a need for computational capabilities. Have a lot of discoveries are being made with help of computational advances. So one thing that made that kind of created is that all the basic science researchers are suddenly have to become computational experts in order to do their science. Right? So we're trying to change that by creating services that help researchers focus on what they're good at, which is basic science aspects, and outsource all the other computational aspects to people like us who are good at or who have figured out how to do these aspects. And some of these things that go into computational aspects of scientific discovery process are data management. Right? So all big experiments, APS, various nanoscale fields, rights, data science and social good, they all generate big data, right? A lot of data that one person or one group can handle. So one thing that Ian keeps joking about is that data is always at the wrong place. Right? So data is at a place where that needs to go to some other place. So one of the things we have worked, or we've been working for the past few years, is build this service called Globus to make it really easy for researchers to move data, to manage their historical data. So if you are a particle physicist, or if you're a genomics researcher, if you are a scientist at APS, chances are you are generating terabytes of data. I say terabytes or petabytes, but really any data that you cannot handle is big data for you. Right? It could be, so I have a daughter, she's 3 years old, and when she was born, I bought an SLR camera like any good father would do, and I started taking all these pictures, and suddenly I found myself having a big data problem. Now I have a terabyte worth of photos that I'm really afraid because my wife would divorce me if I lose any one of them. and it's a pretty big, it has a lot of emotional value to it. So it's a big data problem, so I want to make sure that these are all saved, and when I take one picture, it gets reliably replicated to my wife's laptop, so she doesn't have to. So you can see it sort of permeates in every. You don't really realize it, but it does show up in daily life, not only in the scientific domain. So Globus provides this services that you can go to globus.org and sign up, and you could subscribe for $7, which is not more than your regular coffee at Starbucks. But you can use this service to move data, to manage your data, to share it with others. So that's one thing that we work with. So with Globus, we created this horizontal capabilities, or what I call figuring out who you are authentication, data management, moving data to where it needs to go. So we're still working on these horizontal capabilities, and then we started building much more vertical capabilities that are specialized for various scientific disciplines, and make these services available for researchers. We call them science as a service. So one such service that I'm responsible for building is called Globus Genomics, which makes it easy for researchers who are creating, analyzing genomics data to do it at scale very easily and quickly. Genomics as a discipline it's like writing C programs, or it's kind of becoming one of the basic sciences that has impact across multiple domains, like what Ian told about metagenomics. So naturally, a lot of researchers, are doing genomics-based research, and they find themselves in this problem where they're not equipped to get the insights that they need to get at a faster rate. Right? So Globus Genomics is a service that helps genomics researchers who are getting their genomics data to analyze it at scale using Amazon cloud computing capabilities. So one thing that I'm proud of is that we work with a lot of researchers who work in diseases like autism, type 2 diabetes, MS, cancer. There are a lot of life-debilitating diseases. And I recently worked with a group that was able to analyze a few terabytes of Tourette syndrome data, and we're excited that they found 2 biomarkers that were actionable, which means that they got a good paper out of it, but it also means that somebody can find a drug to cure it or to make an impact of it. So that's just one example of a service. We also took the same principle because it's worked out so well for genomics. We're applying it for material science. We're applying it for climate modeling. So we're building these services for science. So the barrier to entry for end users is very low, and they don't have to become computational experts in order to use computation capabilities to find discoveries, to make discoveries. So we have a lot of problems. So talk to us if you're interested in helping us in reaching there quickly. Thanks.